Okay, so up next we have Chainlink. Patrick.
Hello, hello. How's it going?
Another ETHDenver success story.
Another ETHDenver success story. That's right. This was my first blockchain hackathon, and really where I met the majority of the people that I know in the space. So really excited to be back in this year as a speaker, as opposed to when I was first here, when I was like, what is it? What's Ethereum? What's going on? What is all this stuff? Been very down the hole into the ether, if you will. So excited to jump in. Thanks for having me back, John.
Oh, you got it. Did you get my email yesterday?
I might have. What was the email?
Oh, it was about the state.
It was about the state?
Yeah.
Oh, well, I'll have to check that out after this.
Check it out after you talk. Well, I won't. Don't burden yourself now. We'll talk later.
All right, cool.
Anyways, you're ready to talk about decentralized data.
I'm ready to do it. I'm ready to talk about decentralized data, John.
All right, man. It's all yours.
All right, cool. Thanks so much. Hey, hello, everybody. How's it going? And yeah, like I was just saying to John, really excited to be back, especially here at Ethereum Denver. Last year, I was a hacker here, and this is pretty much where I learned Solidity. I learned everything about kind of the space, got to see who the makers and shakers are. So this is a fantastic hackathon that you guys are at. So you've chosen a great hackathon to be at. You've chosen a great place to be, and just really excited to help everybody on the journey and kind of follow the same journey that I've basically taken in the last year. So really excited to be here, especially for that reason. But let's jump into it. The name of the game right now is decentralized data and empowering your smart contracts to do really whatever you want. And because really at this point in our life, and especially in my last year from ETHDenver to ETHDenver, we have this extraordinary opportunity in front of us, right? The world of smart contracts is really knocking at our doorstep right now. And history is going to show who's going to be the pioneers to push us into this fourth industrial revolution, where we use these superior digital agreements, these superior smart contracts built on top of the blockchain, like Ethereum and all the other chains that are sponsoring this hackathon. So, these hackathons really are the stomping grounds for innovation. So really excited that you're all here, especially at ETHDenver, and excited to take that next phase to help us move forward. But we're going to talk about connecting your smart contracts to off-chain data, financial definitive truth, APIs, provably random numbers, and everything Chainlink. So we're going to talk about Chainlink. We're going to go into the Oracle problem, definitive truth, verifiable randomness, use cases, accessing an API, and then hopefully we'll have some time to get to some technical demos here as well. So in order to really understand Chainlink, we must first understand that smart contracts are not able to connect to external data or really any off-chain resources on their own. And this is a huge limiting factor, right? Because for smart contract adoption, because it means the only thing we can really do is we can do token transfers, right? And this already has been this monumental breakthrough, doing these token transfers and having this store of value. But smart contracts can do way more than that. And it would be great if these external, these smart contracts could actually interact with the real world, right? Because we have contracts that are great, but we would love these math-based, these trust minimized contracts. So then the question becomes, okay, well, why can't a blockchain just make an API call? That's what every other system does, right? Like, what's going on? And that was the first thing that I thought, coming in as a software engineer. I said, okay, look, I'll just make an API call. And blockchains themselves actually can't do this. They can't make API calls. And the question then is, okay, well, why not? And the simple answer is that blockchains are deterministic, right? And this is really important for consensus, because every node needs to be able to validate every other node. And if nodes are calling APIs and maybe they call an API at a different time, that API goes down, it's depreciated. Now the nodes are going to say, hey, what was the response for that API? They're going to say different things, and there's no way that they're ever going to be able to be in sync. They're never going to reach a consensus. And this basically makes it impossible to have that part of the consensus protocol. So how do we interact with the outside world? And the answer to this is using oracles. And an oracle is any device that interacts with the off-chain world to provide data to smart contracts and cause the real world to do things or send data from the blockchain to the real world. So oracles are bi-directional, right? Bring data into the blockchain, send data, or do stuff outside of the blockchain. And they report the result of the, when they're bringing on-chain, they report the result of data on-chain so that the blockchain can stay deterministic. And they do this through an external transaction themselves. So this already is hugely powerful, right? These oracles are really what allow you to interact with the outside world from the blockchain. Now, here's where it gets a little bit more important and a little bit more interesting. The problem becomes a little bit more complicated. We have our logic layer on chain is all decentralized, right? If we're working with Ethereum, Solana, Matic, any other the blockchains that are here sponsoring this event, we know that that logic layer is decentralized. But if we're getting our data from a centralized point, then it's no better than if we just wrote our whole contract in Python or Java or a centralized service, right? Because if there's a single point of failure in our decentralized application, if there's a single person who can twist the lever and turn it off, your application is now centralized. And this is a huge issue. So the Oracle problem can be summed up with these two problems, right? Number one, blockchains themselves can't make API calls. And number two, using a single centralized Oracle is going to mean your entire application is centralized. So you want the logic layer and the data layer to be decentralized. So, and Chainlink is the answer to all this, right? Chainlink is a decentralized Oracle network, and it's designed to be modular. It's designed to be a modular decentralized Oracle network for getting reliable decentralized data. So if you want to get centralized data, you can absolutely do that too. You can run a single Chainlink Oracle or Chainlink node, which is, I'll use them a little bit interchangeably there. But really, if you're looking to keep a decentralized application, you want to use a decentralized network of Chainlink nodes here. And with this, we can use these networks to really take any input, move through the blockchain, and any output as well. So we can really, Chainlink oracles allow you to take your smart contracts from being able to do a lot of things on chain to being able to do anything in the real world. Any type of contract, any type of agreement that exists in the traditional world can be done with these decentralized oracles. So they really unlock the power of smart contracts to go from doing everything kind of in this walled garden to breaking through that wall and having cryptographic math proven contracts in the real world, which is really, really exciting. And to get you started with DeFi, Chainlink has actually already gone ahead and made some pre-box solutions for this. So like I was saying, Chainlink's 100% customizable. You can get any data that you want through Chainlink, any input, any output, do whatever you like. But Chainlink has gone ahead and already done some work for you, right? Some of the most popular data sources right now, especially in DeFi, is it's cryptography prices or cryptocurrency prices, like the price of Ethereum and USD, like the price of DOT, like the price of any token or any fiat currency as well. So the Chainlink team has actually gone ahead, found many of the best node operators on the planet, and put together what's called price feeds or data feeds. And these are decentralized points of reference that anybody can call in their smart contracts and can be considered source of truth. So they have decentralized data in their smart contracts. So here's a visualization of exactly what that looks like here, right? Each one of these nodes in this little circle here independently retrieves data from some of the highest quality APIs and reports their answers on chain. You can see their answers that each provider reports so that everything is completely transparent, right? And most of the most popular cryptocurrency or fiat currency pairs are currently supported. And in addition, there's other pieces of data like how much is in the reserves of TUSD, what's the current fast gas. You can check out feeds.chain.link or data.chain.link to see some of the supported pairs, and there's more in the documentation, which I will show in a little bit. So these are massive for DeFi and have been kind of the backbone for a lot of different projects. And here's just a little bit more information on kind of the approach that the Chainlink oracles and the Chainlink networks take, right? This massive decentrality, provably secure, high quality APIs. And one of the other things that's incredible is the blockchain oracles, the Chainlink oracles are blockchain agnostic, meaning that Chainlink can run on any blockchain that needs data. And there's a reason why I stress kind of the decentrality so much, especially in DeFi. In November alone, we saw over 5 attacks that were over $1 million worth of damage, and the total combination was over 30 million, right? So there were a lot of attacks that came from centralized Oracle attacks, right? A lot of people call them flash loan attacks, but the tool was flash loan, and they were using it to manipulate Oracle prices. So it's really, really important, especially in DeFi, when you're working with people's livelihoods, that you work with decentralized, really secure, really provably honest data, and that's what Chainlink delivers. So, and DeFi again, is constantly one of the major areas pushing for projects and looking for this fantastic data that's really easy to use. And Chainlink is that data that's a backbone of a lot of these projects. So right now, last time I checked, I think DeFi was at like 25 billion. It changes so quickly. It might be even higher than that. But Chainlink is the backbone of a lot of these massive projects, like Synthetics, which last time I checked was 1.5 billion assets under management. I think it's actually a lot more than that at this point. Loopring, Set Protocol, Aave, last time I checked was 3.5 billion, right? So these are battle-tested price feeds. These are tried and true decentralized price feeds that are really going to power your DeFi applications to do everything that we've seen in traditional finance, but in the decentralized finance world. So, and again, check out feeds.chain.link. Also data.chain.link, because Chainlink is expanding to more different decentralized data types. And as the protocol matures even more and more, we're going to see more different types of data. I'm really excited for when I can check on the blockchain instead of like the news, what the temperature outside is or what the weather is going to be like. I think that's going to be really, really exciting. So that's the pre-box solution. There is these price feeds, is these data feeds, right? But Chainlink has even more than that, right? Because again, Chainlink allows you to get any input and any output. So what does this mean? Well, a huge common problem in computers and systems that are deterministic, like a blockchain, is getting random numbers. If you do a random number, in your Python, in your JavaScript, whatever, it's actually pseudo-random, right? It's actually pulling a number from like one of your files or from some bytes or something, but it's not actually creating a truly random number, right? It's getting that random number from somewhere. And this is an issue on a deterministic system like the blockchain. Some of the most common patterns right now for getting decentralized data are hashing the block height, right? And this is actually a major issue because it actually gives the miners the control over the delivery of your number, right? So if you're looking for a random number and a miner gets it, but maybe they have some stake in whatever lottery or game or whatever you're running, and they go, if I publish this block, I will lose. And they just throw it out, and they just keep throwing it out until they publish a block, or until they mine the block that would win, and then they publish that one. Well, basically, this sucks away any and all fairness of your application, right? So Chainlink VRF is a way to get provably random numbers, right? So you actually interact with a Chainlink oracle, it generates a random number, and through a lot of cryptographic magic, and there's a smart contract on chain that actually verifies whether the number is random or not. You can get a truly provably random number into your smart contract. And we're seeing more and more adoption with this as well. Pool Together being one of the major leaders in kind of using the Chainlink VRF to get their random number in their DeFi application. But everything you need for this is in the documentation, and yeah, the documentation link is right there, and we'll go over that in just a minute. And then last but not least, again, Chainlink is capable of being used to work with the APIs that run the rails of the internet right now. So everything that makes the internet run is kind of basically off of APIs, and working with any API is a cinch with Chainlink. And it allows you to not only work with these already existing APIs, but customize them and make them do even more than what they already do. Not only that, but you can also integrate Chainlink with any other blockchain using external initiators. And then this massive customization feature is with external adapters. So we've written a ton of blogs on all this. And we have a hackathon resources list that we'll go into at the end of this, and we can show you guys where you can see some of these resources and where you can customize your smart contracts to do literally anything. And yeah, and here's the just a quick snapshot of the documentation page, which shows getting an HTTP GET request. And we'll go to the documentation in a second. But before we jump into that, I wanted to jump in some of the use cases enabled by Chainlink. So there's an article out there called 77 smart contract use cases enabled by Chainlink. Definitely go check it out. If you're looking for ideas, if you're trying to get started, it goes through way more than I'm going to go through here, but I'm just going to briefly just run through a couple of them. DeFi applications. I mean, we're basically speed running the traditional finance history, and there's still so much to do. So there's a ton of DeFi applications, and obviously getting data is the cornerstone of a lot of these DeFi applications. So definitely take a look for some DeFi ideas, fantasy sports, or really any type of gaming that needs randomness or any interaction with the outside world, tokenizing your assets, or insurance. And insurance is kind of a huge one for me, and one that I'm really personally really excited for. We're seeing more and more adoption on this as well. Let's say your crops get all messed up due to the weather and your insurance doesn't want to pay because of some pre-existing condition, right? With a decentralized smart contract, you don't have to trust the insurance company is going to do the right thing, since the right thing is going to be infrastructural with Chainlink and getting that data. So incredibly exciting here. So let's go through a couple of demos here. And hopefully we can see the docs. Yes, we can. Great. So here's the Chainlink documentation. For those of you who are looking to get started, I would say just come down to Hackathon resources, right? There's a ton of information down here. You can go through some of the frameworks that have Chainlink natively in them. You can come to the different support channels. Discord there's a massive following of Chainlink and smart contract engineers who are really helpful, looking to help each other out. And then we have a bunch of tutorials here as well. If you've no idea what any of this Ethereum is, but you're really excited, you heard a little bit about trust minimized smart contracts, or you're really into the tokenomics or whatever, we have some beginner tutorials that are good for anybody just looking to get into the space and looking to work with data. And there's also some past winners in here, some other blockchains, but this is a great place. The other great place to look at is going to be the Chainlink blog. That's at blog.chain.link. You can check out the developers channel, and there's just a ton of tutorials in here. NFTs, insurance, different blockchains, different languages, Python, hard hat, truffle. There's a ton of information here if you're just looking to get started, you're looking for some more information. But let's go ahead, and we're going to actually start with the price feeds and getting the latest price of a currency pair into your smart contract. So we're going to come right here. So it's going to be using price feeds, get the latest price. And all the code that you need is right here. So this is this is set up for your truffle or your hard hat or your brownie. We'll actually deploy with Remix because it's a little bit quicker. It's a little bit faster for us to try out here. You will notice the syntax on Remix is a little bit different. And I've done this a lot, so I have a lot of stuff. But normally you'll just get one contract here. So the only difference with Remix is that you actually pull directly from GitHub in Remix, versus with like Truffle, Hard Hat, Brownie, you pull from like the npm package. So we're actually gonna pull right from GitHub, and we can see in here. And I'm just being conscious of the time, that's why I keep looking up. And we can see in here, this is all the code that we need. So we have our contract. I'm gonna move this over just a hair. Cool. We have our contract that's called Price Consumer V3. And what we're gonna do is we're gonna import this aggregator V3 interface. This is the Chainlink contract that actually aggregates the data of all those nodes. And we need the address of it. So we need this address right here. And we can actually see this on the Coven, we can actually see what these price feeds look like. This is obviously the mainnet example, but if you want to see it on chain, right, you can go to Etherscan. You can see exactly the contract, and just read everything off of it. So, yeah, we can view advanced mode, see a whole bunch of the different transactions that are going on to keep these price feeds up to date. But yeah, so we're going to use the Coven testnet to test this out. And all we need to do is call this get latest price function. And this is a view function, so it doesn't cost us any gas to actually call it, because we're just reading something off the chain, and it's going to return us the price. So we're going to go ahead and compile this, which I just hit Control S to compile. Oops. Compile it, and we're going to deploy it. Inject a Web3. I might be on mainnet. So let's not be on mainnet. Oh, you guys can't see my MetaMask because it doesn't let me. It doesn't show the application window, but my MetaMask just popped up. I am in Coven. We can even see that I'm in Coven right here. We're going to use inject Web3, which means we're plugging in our MetaMask right into here, and we're going to deploy. MetaMask again popped up. You guys can't see it. I'm going to hit confirm, and we're going to get this transaction down here saying, okay, cool, you're deploying your smart contract. So again, this is just deploying a smart contract that once it's deployed, it's going to read from this address, this decentralized data on chain, and we're going to pull it, and we're just going to read from it, right? So now we've deployed our contract, and we hit get latest price, and we can see the latest price of Ethereum. The question then is, oh, well, why is it a weird number? And the answer is because Ethereum actually can't understand decimals. It doesn't work with decimals. So we actually just multiply it by, what is it? 1, 2, 3, 4, 5, 6, 7, 8 zeros. And we see the price is actually 1,560 right now. which is really exciting. So this is how price feed works, and we'll jump back into the next one. And again, head over to data.chain.link. In the price feeds themselves, if you want to see, all the different addresses for, right now it's Ethereum, Binance Smart Chain, and Matic. We can jump here and we can see all the different price feeds. There's a ton, and on the different networks as well. And you just grab an address, you pull it in. The other thing that's really cool is you can actually work with ENS, the Ethereum naming service, to get this decentralized data. Instead of like grabbing the address, you just do, you look up the ETHUSD. I think, ETHUSD. So here's the name, ETHUSD.data.eth, and here's the address here. So you can use this instead of always having the hard-coded addresses, but you can use whatever one you want. So that is price feeds, and that is, like I would say, that's one of the most powerful features, is these pre-boxed decentralized solutions that you can use to get decentralized points of truth in your smart contract. You don't have to worry about figuring out where to get data from. The next thing that we're going to look at is getting random numbers into our smart contracts, and this is huge. And we saw the use of this actually at another ETHDenver event, the Game Jam, Colorado's Game Jam, which was really cool. We saw a number of projects using these random numbers to help kind of redefine and rebuild some of the different things in the current like Web 2 like lottery world, so we can have these provably fair lotteries, which is just kind of an insane concept that's even a thing. And again, all the code is here. This is kind of the truffle hard hat version we can deploy with Remix, like so. And again, I've done this 100 times, so I have a ton of contracts in here. But what we're going to do here is we're going to import VRF consumer, and that's the code that's going to really that's going to provably check that our number is truly random with the oracle that we use. So a couple additional things going here. So we need the key hash of the oracle that we're going to work with. We need the fee, because in order to work with a Chainlink oracle, we actually have to pay a gas fee, or excuse me, an oracle fee. And then we're going to have just a global variable called random result. So in our constructor here, we're inherited the VRF consumer base, and we give it the VRF coordinator. This is the VRF coordinator address. This is the smart contract that actually cryptographically checks that our number is provably random. We have the link token, which is just the address of the Chainlink token. And then we have our key hash. And this, combined with the VRF coordinator and the seed phrase, which we'll get to in a second, are all the pieces that the smart contract needs in order to prove that the random number given is truly random. So, and then we have our fee, which we're going to set to 0.1 link to work with the Chainlink oracle here. Now what's going to happen, we have a function called getRandomNumber, which we give it a user-provided seed. And this is something that we come up with. We've seen stuff like protocols like Pool Together just use the hashed block height. And this is a seed that we give it so that, again, the Chainlink oracle can use that kind of as a base to create the random number. And the VRF will actually take this seed and use it to prove that the random number generated by the oracle is truly random. And then we just call this request randomness function, and we send, give the key hash, the fee, the user provided seed. And this is imported from that VRF consumer base, which we have at the top here. So this actually makes, to do this, we actually do two transactions. So we call this get random number function, and it emits a log that the Chainlink node off chain reads. It picks up the log, goes, okay, they want a random number, great. Generates the random number, and in a second transaction, it actually calls this fulfill randomness function, calls it back, returns the randomness number and also the request ID, but returns the randomness number. And you can do whatever you want with that random number here. If you want like a number 1 through 10, you can use module, module 10, which this actually makes it a random number 0 through 9. And we're just going to set it to random result so that then we can read it. So this is the callback function that the Chainlink node returns with. So same thing, we're going to compile it. We're going to move to injected Web3, and we're going to deploy. Again, MetaMask pops up. I'm hitting confirm. You guys can't see it. And yeah, same thing. We have the Coven Etherscan link, so we can see it actually being deployed. And we get the random number consumer here. Now I'm actually going to call it wrong intentionally, just to show you guys something that you'll probably run into. and you'll be like, what's going on? So we get this gas estimation failed. And the reason that we get this is, again, to work directly with the Chainlink oracles, we need to send them a link token. We need to send them this oracle gas. So we're actually going to copy this address, and in my MetaMask, I'm going to send it. Excuse me, I'm going to send it some link. And apologies, MetaMask doesn't show up when I'm doing the applications screen, but I'm sending it. I'm sending it a couple link. Here's the transaction for it. And if you want, like, Coven link, and it looks like it's already done. You can just like Google Coven link faucet, right, and it'll pop up. Same thing with Coven ETH faucet, or whatever network you're working on. You can get that into your smart contract, no problem. So now it's funded with Link. Now we can call this get random number, and it doesn't give us that error. Again, MetaMask does pop up. You guys can't see it here, but I'm going to go ahead and hit confirm. So it's going to make 2 transactions, right? Once this one completes, our Chainlink node is going to read it, pick up this request, and then say, okay, cool, they need a random number, and send it back. And if it's not random, this VRF consumer, this VRF coordinator is actually going to reject it. So hopefully the Chainlink node actually sends us a proper random number here. And and then we also specify which oracle that we're going to work with, which is imported from the VRF consumer base. So once we hit random result, now that it's actually responded, we can see we have this massive random number here. So, and I have a couple minutes left, so I'm going to try to speed through the last example here, which is making an HTTP GET request, which again, if you're interested in kind of customizing this so your smart contract can really do anything, definitely scroll down to the external adapters. We've got a blog, we've got a video on the whole thing, like building and using external adapters. The blog here, there's a video here. We have got a whole bunch of videos on the Chainlink YouTube. This is how you can kind of customize it to do anything. If you're interested in building kind of your own solution with other chains, check out external initiators. And yeah, again, Hackathon resources is a great place to go. You can see some example winners from the past. There's a lot of really good stuff in here. But yeah, for those of you looking for support, definitely jump into the Chainlink Discord. But yeah, I'm going to speed through this one as well because I have a minute and a half left. And this is just making an API call. So again, we're going to pop up MetaMask, and all the information that you need is in here. If you have a question, feel free to Google it or ask in the Discord or ask somewhere. This is pretty much the same as getting a random number. We're going to import some code. We're going to choose the oracle. The only difference here is we're going to choose a job ID, which is going to specify what we want that job to do, the return type that we want to get. And we're going to call this request volume data, which is actually going to call this, make this API call right here. And we're going to look for the last 24 hours. We're looking to get this into our smart contract. So to our Chainlink request here, which you build it like this, we're going to add this HTTP GET, what's called an adapter. And we're going to say, hey, we want you to make this API call. And we say, off of this API, we only want to get the path of raw ETHUSD volume 24 hour, which is going to be raw ETHUSD volume 24 hour. We're saying we only want this data. Obviously, if we grab this whole thing in, that's going to be very gas expensive. And remember, Ethereum doesn't work with decimals. So we're going to also add this, this times adapter, which is going to multiply that number by this. And then we're going to send the request to that off-chain oracle. And then it's going to return with this fulfill function. And yep, just speeding right through, because I have 0 minutes left. We're going to deploy. We're going to deploy, confirm, and then once it deploys, we're going to grab it, send it some link, because again, it's the same thing as getting the random number. We need to send it some oracle gas. Again, apologies, you cannot see because the StreamYard isn't letting me show the whole screen here. But I'm going to be sending it some link, and then once that is confirmed. Still sending. Once it's confirmed, I can now request the volume data. MetaMask pops up, says, are you sure you want to do that? We're going to say yes. And And once the transaction goes through, right now, if we click this, it's going to be 0 because we have to wait for the oracle to see the request, make it off chain, and then return it back. And once this returns it, then we'll get the volume. And you can see how very easily, if you make the request to a network of these nodes, you can get decentralized data very easily. There are node listing services like market.link where you can check out all the different nodes that are on the network. You can choose, you can mix and match and make your decentralized network of nodes of whatever you want. And again, we get the number here, which is multiplied by this massive number. So we have the volume in our smart contract. So really excited for everyone to build at Ethereum Denver. Like I said, this was my first blockchain hackathon. So this is of particular interest to me, John. You guys always put on a phenomenal event. So just really excited to be back and giving a talk this time. So I will be in the Discord. We will be in the Discord, the ETHDenver Discord. Feel free to stop by, say hello. I was in the castle for a while yesterday. I will probably be there again today. Feel free to stop by and say hello and tell me about your projects and what you guys are building.
Cool. Thanks, Patrick. It's great seeing you, man.
All right. Great seeing you too, John. I'll check out that email right after this.
Sounds good.
All right. Take care, guys.
See ya.